We're going to start moving.
Okay.
All right, well, I'll talk while you guys are looking out the window. Okay, well, thank you all for coming today. We're here at the Douglas County Replicated Tile Drainage Site, which we started in late 2014. We're on the north side of this ditch here. There is a map, and but we're going to stop and you can look at it if you're challenged by driving and looking at a map. But across the ditch you can see our first 12 automatic water samplers and tile monitoring stations. And we're using an old nomenclature here. You're looking at 4 through 15. Bob Haft and Emerson and a team of scientists back in 2001 through 2004 used this site, and they used 54 tiles. So when Cameron Piddleco came and worked on this data, he said he'd share the tile flow data with me. So we picked the 36 tiles that were most similar in flow. So we ruled out some, it gave us a little better ability, I think, to detect differences in load since we had this previous data that we could work with. So that was a real advantage for us. And so, and we didn't use some of the tiles that had surface inlets on them that had been put on since Bob Haft was out here. And also there's some low areas, drowned out spots that we stayed away from. So we were able to find 36 tiles that perform nicely for this experiment, and they're embedded across this entire farm. As you can see, many of these tile runs are 2,000 feet long, so 3/8 of a mile. There's a weather station coming up. Our truck is passing by it right now. So we have rainfall, temperature, relative humidity, light, wind speed, everything you need to predict evapotranspiration. And on the other side of the ditch, we have soil sensors in the ground at different depths, so we can see the influence of soil temperature annually. And off to our right, there's another set of ISCOs and water sampling and monitoring area. We have 6 treatments out here, and there's blocks of 6. So each treatment is randomized in a complete block design here. So all 6 treatments are in each one of these blocks, and we have both phases. So we're monitoring tile nitrate coming from soybean and corn simultaneously. So 6 treatments, 3 replicates. That's 18, and then both phases of the crop rotation. That gets us to 36 tiles. And the treatments are mostly based on the timing of end application differences. And then one treatment has a cover crop. And you can see our corn rows are running east and west here. And those tiles are also about 2,000 feet long. So each plot is about 4 acres. Each one of these tiles is 100 feet apart. Sometimes we skip one, you may notice, because that's got a surface inlet on it. But to have 4-acre plots, it's pretty impressive to have that large of a plot for a replicated tile drainage study. So we're coming up on the division here between the 2 phases of crop species. We've got some equipment up here too that you'll be able to see. Okay, Dan has informed me we're going to drive past the equipment, and that's going to be our stop at the end. We're going to go on past that and go to the end of this experiment so you can see just how much area of this farm is being used for this experiment. It's a big experiment. And Dick Searles is the owner of the land, and Dan and Eric do the custom farming. And since we don't have a tenant like we did the first 2 years, we can get things done quickly and very timely. It's not that we had a bad time with the tenants the first year. It's just they have other priorities, and yeah, sometimes we're not one of them. Yeah, beans are looking good. Of course, we thought if we scheduled a field day today, maybe it would rain on us. But no, it turned out to be the hottest day of the year. A little unlucky there, but we could use the rain. Everything's off to a great start, though. Yeah, we're going to start our turn. So this is, we're turning up by number 21, and then 20 is the farthest one. Might be hard to see those numbers on the map, but they're the 54 numbers that Bob Haft used. We just didn't want to change the numbers because we chose those plots knowing something about the tile drainage. So we just kept the old nomenclature. This is quite a parade. I'm waving at you guys. Okay. So very briefly, the 6 treatments is 100% of the nitrogen applied in the fall with an inhibitor. And then back in 2014, we were thinking maybe a 3-way split was the way to go. Try to spoon feed the crop, but also get half of the nitrogen on in the fall. And then 25% at planting and 25% side dress. And then there's 100% anhydrous ammonia in the spring. That's without an inhibitor. Oh, and by the way, the 50% in the fall does get an inhibitor. We don't actually have treatments that can test the efficacy of the inhibitor. We either have the inhibitor applied with fall N or we don't. And then we have a reduced rate, which turns out to be an important experiment treatment because we want to make sure we're not over fertilizing. And sure enough, by only putting 75% of the fertilizer on, we do not get maximum yield. That's been about a 10% yield hit, not having the full rate on. And then we have 2 treatments that are 50-50 split, spring and side dress. And it's an early side dress. And then treatment number 6 is that same 50-50 split with a cover crop. And we've been using cereal rye after corn ahead of soybean, and that's been working great. That has not caused us a yield hit, and it's greatly reduced the tile nitrate load. But we've been challenged on what to use before corn because we don't want too much biomass. So we tried oat and radish the first 3 years, and we never saw enough biomass to reduce tile nitrate. So we switched to annual ryegrass, and the polar vortex killed all that. So we moved on, and this past winter we tried winter wheat in front of the corn. And that seemed to have done all right, and I don't think it hurt the corn yields. Well, we don't know yet. We'll be harvesting that here in a month or so. So shall we get out now, Dan? All right, we're going to get out of the vehicles and take a look at one of these monitoring stations.
Very well.
All right, well, here we are. I'll go with the monitoring equipment first. And we don't have any tile flow, which we're glad of because we have collected a lot of samples this year already. Nice to be able to catch up in the lab. So many samples. And we've just taken one sample, say on a Monday and a Wednesday and a Friday. That generates the 36 times 3 that adds up to it. And then the 5 different aliquots that we're measuring. We're looking at nitrate, ammonium, dissolved phosphorus, total phosphorus, chloride, and sulfate. Those are the things we look at. We also look at turbidity sometimes, if there's a relationship between turbidity and total phosphorus. And so we've got a pressure transducer down here. So we're measuring the height of the water over a V notch. And you can't quite see the V very well because it's so far down there. But this pressure transducer is submersible, so we can pull it right up. It's on this clothesline. And you never have to get into the pressure transducer. It's got this downloader that has a window. So it just looks through a window and grabs the data that way, so we don't have to worry about taking lids off and getting equipment wet. They're meant to be submersible. We also get tile temperature, which is quite interesting. It'll get down to about 38 to 39 degrees is all it ever gets down to. It never gets down to 32, unless you have a snow melt. And then you can see the tile water go right down to 32 degrees. Quite interesting to see that. Or if you have a warm thunderstorm on top of cold soil, you can see the temperature rise. So you know that you're getting the first flush from a rain event. You see the tile temperature. It's very nice to have tile temperature to help us when we're choosing samples. Now we sample every 8 hours, but we don't save all the samples. Pick and choose. Well, if there have been no rain events for a week and it's been baseline flow, tile nitrate hardly changes at all. So we only need one sample that week. But if we have a big event, we want the baseline, we want to catch the peak, we want a couple on the way down on the hydrograph. Hydrograph of a tile event, very sharp up, and then it goes down. Looks like a dorsal fin on a shark. That's how
so they're strictly on a time clock, yes, and not on a pressure situation.
No, it's not like flow proportional. That's a little more complicated, and we've got a full-time field tech that practically lives out here, and this is Dan's home away from home too. We got it covered with having every 8 hours. See, we sample at midnight, 8 a.m. and 4 p.m. every day. That'll catch an early morning thunderstorm. We don't get many of them. An afternoon thunderstorm in the day, and then late. So we're never too far off from high flow. If we were going to do a phosphorus study, we might have to have more samples at high flow. We just published a paper on our phosphorus data, and they made us take out everything we said about preferential flow. They felt we needed more samples at high flow. But nobody has any problem with the amount of sampling we do for nitrate. We do for nitrogen experiment. We're just happy that we could publish the phosphorus data. And this farm is losing very little phosphorus, by the way. We have a 27-year record of river nitrate at Camargo. So we're in the Ember watershed. The Ember is passing by us here to the east. And for 27 years, we've been sampling at that bridge. It's just coincidence that watershed loses 27 pounds per acre per year. So this site is losing about 25 pounds per acre falling. And as little as 14 pounds per acre in cover crop treatment. So that's our swing. We've got 4 years. It's one of our data slides, and I can show that to you later. But we do cumulative load. So we know tile flow every day, and we have the nitrate concentration or phosphorus. And so we do what's called a linear interpolation between time periods, because we have flow for every 15 minutes. We don't have a nitrate concentration for every 15 minutes. So we have a nitrate concentration in 2 time periods. We fill in linearly flow times concentration. Load, we sum the load up every day. That's our cumulative load. And now we got a 4-year graph from out here with cumulative load. And we could divide it by 4 and know what the average loss out of each treatment. And so it turns out that we have reduced tile load by 40% compared to the 100% in the fall. For the cover crop treatment, 50-50 split of the 2 cover crops, on average, over the last 4 years, have lost 14 pounds per acre, and the fall-in plots, ripping and heavy, lose 25. And so that 10 divided by 25 is below 40%. So that's the span. That's the separation of our 6 treatments. And it works better than I've ever could have imagined. I was very worried that these tiles are 100 feet apart. And what if the edges are squishy? What if some of them nitrogen moves that way or that way? It does. So we're monitoring the soil above the tile. So what moves through the soil and gets in that tile, because we have such a dramatic effect by material rye and corn, or we can see fall in, which is strange. We can see a nitrate pulse with fall in
just a few days after we put it on. That's still mind-boggling. I still don't know how that happened. Because we put it on as ammonia, and yet we get a little uptick in nitrate with the very first rain.
Tell them about the pulse you saw with the spring applied diammonium phosphate in 2016.
Oh, right. So that was, we saw ammonia go up in the tile, and we saw phosphorus go up. And we had DAP out here and triple superphosphate, and the concentration of the tiles, phosphorus concentration of the tiles that had the DAP was twice as high as the triple superphosphate. And that was just we weren't really trying for that experiment. And it's just, we already had our nitrogen on in the fall treatments, and the owner wanted phosphorus fertilizer. Oh, the tenant at the time.
He had to put, and we didn't know who the tenant was until March 1st, so they came in, and that's when the tenant is named for this farm. That's the last year we had a tenant. Let's put it that way.
So we already had all our N on, so we couldn't use that on the fall end plot. Right. So Dan found triple superphosphate, and we put that on the 6 fall end plot. So we had 6 plots with triple superphosphate and 12 with DAP, and I averaged the 12 and the 6, and the concentration is twice as high. DAP is more solid. We weren't looking for that experiment within the experiment within the experiment, but we have some of that we can learn from other things. But the main experiment was 6 nitrogen treatment. But like I said, the phosphorus concentration is low out of this farm. I was talking about what we found in the river. The river loses about a half a pound of phosphorus basically left of the tank. The river transports about that much. And we then averaged across all 36 tiles for 3 years, and it's only 14% of the river's phosphorus that's coming out of these tiles. It's really good, right? We're not part of the phosphorus problem, at least this one. I don't think our tiles are phosphorus. We hear about that when we've done no-till for 20 years or 40 years in Ohio, and now they've got this stratified layer of phosphorus, and it seems with preferential flow, it's carrying phosphorus to the tile. We're lucky we don't have that problem. In best laid plans 40 years ago, everybody should move to no-till. And now you got a phosphorus stratification problem. So,
would it be different if you had spacing with your tile? So the water didn't have to, so the water didn't have to move through as long of a soil profile to get to the tile, and some of that phosphate being tied up that way. Because the pattern now is to go much closer spacing.
That's a good point. They always say that if you put in more tiles, you're going to probably outlet more water. There's more water. But some people say that, well, it just drains out that, not any more water. But there's still debate about it. And I'm pretty sure that if you move to 50 separation, then you would have so that's a good point.
And that is one of the studies with Rabin. He's working on tile depth and spacing.
What is the size of the tile?
These are 5-inch laterals. They were put in by Bill Dean. The guy's still around when I was medicine. I could talk to him. Every now and then I would curse Bill Dean because we couldn't find the tile. We had a tile program out here. No tiler from the 70s ever thought his work would be checked more than this. We were out here with a tile probe every 6 inches trying to find every one of these. It was easier to find them. It's amazing when you can sort of see the tile when it goes through the grass. The grass is a little greener. But it's a 5-inch tile going into probably 12-inch main. And we intercepted these laterals right before they get to the main. The main, main's about 10 feet, maybe just a few feet behind the beam, going this way, and you'll exit somewhere.
On your layout, then, a lot of times during the spring rains, these are running completely full. 5-inch tile running 2,000 feet.
Yeah, well,
it's going to be, or a 100-foot center is going to be very full.
It's a lot of water.
And then if you're on the downside of the main, close to the outlet, where your main is completely full, or is it a possibility you're going to have a different flow in those laterals? laterals that are.
As if we're impeding some water with back pressure?
Exactly.
Yeah, we have worried about that. We've seen that. So the ditch will get high and then stop off high. And then it's just an imminent release. So then we have to wait for the ditch to go down. And not all tiles clear at the same time. So we we stagger them. We make sure we hit high flow. Each individual tile. Not so much, well, this is the time we go out. So we have to be mindful that some tiles will play because of especially the ditch stuff.
You change the box setting as far as the gate, that getting the box.
No.
Or are they preset?
They are set.
One time.
Yep, they're set one time for this experiment. So we don't want to change, because if we lift them, we cut that. So they're all set, and they agree with each other the way they're all set now. Eric, he's got bioreactors, and so then we do change the set, and that does change how much comes out of the pile. It's sort of maddening to a researcher, but we're getting a handle on how much we hold back. But the bioreactor, with all that back pressure, holds back about 50% of the pile flow. And people aren't looking for where that water goes. And I think that's still carrying tile nitrate. I think it's carrying nitrate in the wintertime, same concentration.
And from a farmer standpoint, cutting my drainage at half when you do that.
Yeah.
So that I think isn't getting enough thought either on the effective drainage.
I agree with that. Yeah. But so Ruth Brooks is the ag engineer that looked at Eric, and he said, well, I didn't design these bioreactors to be watertight. If they leak, it doesn't matter, because he said, well, there's 30 feet from here to the ditch, and it'll be nitrifying. I argued with her. I said, well, not in the wintertime. So we're still getting together and working on our differences of research and interpretation.
And we only change those stop logs generally, we pull them probably around April 1st.
Right,
to get
because
the water off.
That's a great release. So then we remove the board. So the bioreactor's like decommissioned for a month, or however soon it can plant, get the field ready. One time it took 6 weeks because it started raining. And so all that water then goes to the leaching. That's just an issue. He doesn't want the field flooded when he's out there working it. And there's also a different setting. We follow Ruth Book's guidance, based ag engineer. And she has this 24 inches of back pressure on the pile in the wintertime, as much as 36. The difference in, I should show you this maybe, but anyway, there's a difference in the reset of how we push water through the ditch. And so there's also a setting for in-season. And so there's a fallow and an in-season. In-season setting is much lower. But it pushes some water through the woodshed. So those are things that we're trying to work out. I think all that needs to be better before it's a technique that is recommended. I'm not quite encouraged with that.
Yeah. Made myself go back and work subsurface irrigation. And one of the hardest things to do for me was to manage that water table out there. The rain event that's supposed to be 3 inches is coming on Friday. So all of a sudden, I want to get water holding capacity out there, so you pull the gates. And then it doesn't come.
Yeah, right.
It's extremely difficult to manage that.
It's not a set it and forget it. Like
No.
A lot of people want to believe that you can just go out there, set your bioreactors, and come back and do it.
And then the question that I've yet to have somebody answer is, what am I doing for the biolife of that soil?
Drowning it?
When that water table, when I don't get it out quick enough and I flood that field.
Yeah, I don't think it's doing anything to soil health, is the one thing. And that's the thing about cover crops and adding carbon, if we move towards carbon accounting, and if we actually have carbon credits to try and offset what goes into the atmosphere, and give agriculture a credit for sequestering carbon, cover crops are going to play a big role in that. And the pipes are not doing anything. Okay. You keep the water table higher, so you would slow down mineralization. But I don't think it's keeping the water table that high. Here's the thing, when I showed the data to this book, when we see that the water level get right down at the bottom of the beach, you see that it doesn't hold there. It just keeps on dropping. So it's not performing drainage water management. Even though Eric's field and this field would qualify, maybe it's almost too flat. Eric's field is quite flat, so it qualifies as the drainage water management field. You have to affect by putting the boards in at least 20%. Even one of your fields like 50%. They're at least affected by having spiral. Where are they going with all that?
It's tricky.
Yeah, it's hard to manage this. The bioreactor is not set up together. You can see what your cover crop is. And the first time we tried cereal rye out here after corn, that was a 43% reduction in farm output. The first year we tried, it was 22 when it was 22 pounds per acre loss from the other 5 soybean treatments. And there's 6 treatments out there, so corn treatment and soybean followed it. But the one that had the cereal rye was 13. That was 9 divided by 22, it was 43%. So that's a great reduction in farm nitrate. Then you added carbon. Tell you that cereal rye, which was 1.25 tons per acre of above ground biomass, reduced that tile load, like I said, and you still got 80 bushel per acre soybean, 4 acre plots. And the average of the 3 plots with cover crops was 80, and everything else was 80. We had 80 on wherever the soybean was. That was the finest soybean I'd ever seen. And then he went and beat it 2 years later with 97. On how many acre field was that? I thought it was 74. 74 acre field. He got 97 bushel per acre. And that was 2 years after we had red clover in his wheat. And the red clover end credit did not translate to the corn, but then he gets huge soybean yield, bigger than the conventional. I'm jumping the gun. And we talk about red.
And I think Dale's got a question.
It's all swamped together in my mind.
We were talking about the outload of your application rate of like fertilizer out here. Has it changed since 2014, or are you still doing P&K the same way? Is it still
2016 was last year. Phosphorus and potassium was applied. We've got a K level of 340 to 400 out here, and then the P levels is 45 to 75 is a range. So they haven't been putting on phosphorus. The pH was low, so they've been working on the pH every year for the last 4 years. We have not done any phosphorus potassium application. So that has changed.
Oh, that's why I was questioning, talking about how these started down. Because those of us with strip till and all that are having issues with continually applying that on the surface. If you're going to plural about what you talked about there on Ohio, that plural, and how we manage that. That's why I was curious how you manage it here.
But one of the things I think of with strip till and deplacement, I think, and that was one of the things I wanted to look at, was if that knife goes through and smears those macropores, we're placing that, nesting that phosphorus in, I think we'll have less loss. The loss came from that broadcast application before we even had macropores built, because it was conventional till the year before. The last 4 years has been the conventional or the conservation tillage. So even in the conventional tillage, we had that preferential flow, that DAP and the DAP.
Mm-hmm.
So
did we fertilize both 15 and 16?
they may have done 15. I don't know what.
We weren't sure about.
We never saw them come in. We don't.
Our phosphorus evaluation was just the first 2 years, 2015, 16. So we did at least have one fertilizer. It should be lower now than it was on.
Right. Well, the soil test isn't showing that. What I just gave you was this summer soil test.
Oh, and it's not showing.
We're not showing real low P levels, especially in your low depressional areas.
And you alluded in your visit on the way out here, you talked about your struggle to find something to use behind soybeans ahead of the one. You talked about your struggle with the rye and the better wheat.
We try to look at it.
Right.
Right. The real benefit of steel rye is from on I think it's almost no different than but when it comes on in spring,
what rate are you
winter. Oh, as far as
rye, what you're
pounds of bin run wheat last winter. Is what we were.
We don't have a lot of money into our cover crop.
No, that one we didn't. And then the cereal rye is right at 63 pounds.
If you're doing that, no telling that it's stocked right after harvest.
No, I take that back. We've done it both ways. This past summer, we brought in the Hagee from over by Decatur. I can't think of that. He's on Twitter all the time. You know what I'm talking about. Dennis Ford. Yeah. He brought his Hagee over and we dropped it in last September. And so the year before we drilled it. So we've done it both ways. Last year's stand was fairly decent. I don't know what the biomass was. Maybe you don't know. But that's, we've done it different ways.
We didn't quite get to half the time period.
We tried aerial once. Didn't like that at all. The soybean, the wheat actually gets drilled in with his no-till drill into the bean stubble. That we do. That's how we're doing the cover crop in the soybean stubble. Oh.
What stage of the corn when you put it on? It was like a baby or whatever.
So it was mid-September last year, so we had fairly good amount of light penetration at that time. The thing we lacked was just a lot of rainfall. Yeah. We got it going, but we could have used a little bit more rain.
Just trying to think about when we run wheat. Four crops in 3 years. We're doing double crop beans behind the wheat, and then coming in with corn and maintaining it. Biomass. It's one of our issues is to get in and plant in July. The same challenge there. You've got the same wheat double crop. And it was that wheat mat that
Well, I'll talk about that when we get back to my place. I've got
what we've been doing with that is vertical tillage, and we can get the soil firm enough to process and spray. We don't want to get rid of this because we want to fluff it up, but let it get some air. Don't we have that treatment done at the farm at the washout?
That's an NREC study too, right?
Yeah. You got vertical till versus no vertical till? Right. This year, it was it went to beans with just vertical tillage on one area and nothing on the other. There was no. When we do put phosphorus on, is to put some and then work it in one place and do the vertical tillage prior on the other one, just to see what the surface come out with. So I got to point out, all mouses. We have mice living up here and here. It's just every time you pull a lid up, mice will go jumping out of them. All this grass, they come right up under these things. So we have figured out how to keep them off. If there's a little sag right here, that's trouble. So I got to be careful when I put that. Mice cause such problems. We have a full-time field person. I think he's rooting for a drought because he's had so many right here. He hasn't had a real vacation in a couple of days.
Hope for a drought. We hope for rain, but not too much to get tiles.
Okay, there you
said
go.
that to me many times.
Okay.
So that's kind of our common ground.
3/4 of an inch is fine.
3/4 of an inch weekly is fine.
Yeah, no. Yeah, he's a team player. He
Yeah,
would
he's
do a drought. I should never. Any other questions?
So, curious, are you taking any tissue tests of the corn and the beans?
Yeah, that's what the F-farm money is for. It's a lot of 36 tiles. Then we have this supplemental money. So we do inorganic N soil sampling, 0 to 1 and 1 to 2 feet in the spring and in the fall. We harvest corn at about V8, and we send that off for analysis. Then we do chlorophyll feed. Bad news. Then we do a leaf harvest, the ear leaf harvest at flowering, and also chlorophyll. Get that leaf. And then we just did R3 mid-grain field chlorophyll, and the Lowell Gentry just kept separated. Low chlorophyll. And you said you could see the drone shot.
Yes. The thing on that FR money though, that ended, right?
It ends this fall.
Right. So you don't have
We're still going to do the soil sampling this fall, and there's a soil health map. And that gets sent to what's called the soil filter. I don't know. But this study is part of 7, so a total of 8 replicated tile drainage studies from Guelph, Indiana, Illinois, Iowa, one in Missouri, and one in Minnesota with problems. There's 8 of them. And we put all of our data together on one massive website. It's a data repository held by Purdue at this point. And so all of our tile flow data for the last 3 years, all of our nutrient data, all of the plant samples, it's going to be amazing data that these 8 all together cooperate. And this is the end of it. But of course, we just had a phone call together that's talking about how do we extend this, or we're going to get a 6-month no-cost extension. That's fine. Doesn't help that much. That's just really things up. But I had anticipated not getting an extension, and the cost of those analyses is then put into the end of that
21,000. Part of that increase.
Yeah. We had KSI out of Shelby go through all our soil sampling. They come up getting 2 men crews. Oh, it's good when they're doing that.
So there's 6 crews out here pulling the nitrate sample.
It's amazing. You get it done in one day. Send me out with a probe in one day and I'd be dead. We'd never get it done. So they do that for us, and they do the soil health, which is a different core, and it's a different depth, bigger core, and then they put all those samples together and labeled, and they send them to that Iowa lab. And I don't know if they do more than one type of soil health analysis, because we got plenty of soil. I have not seen that soil health. I don't expect it to change and mean that much in 4 years, but it'd be nice to see how different it is every year. And they've got 2 years of soil health data, and that's a health issue. First, the leader of that lab retired due to health issues. I know they have the data, but they haven't released it to me. I can't wait to see what kind of ballpark the soil health numbers are. But since we've moved to strip till, we think we've got a permeable soil that can handle these big rainfall inundations, and we have less standing water. So this is the bottom of an elevation of lacustrine soil, and farmers in this area fight close pressure. They fight ground out. And that's what this phosphorus paper showed, that these close depressions end up having more phosphorus in them. Soil moves to the low spot, fertilizer, and you got a tile into that, and those tiles carry the most phosphorus. But the most gee-whiz thing we found out here, the farmer didn't even know existed. And so 3 of the tiles go through where an old farm bed was. And that, see, when we're on a 2.5 acre grid, you miss a lot. And one sample came in at 290 pounds per acre phosphorus in 1,100 tests. So what's going on here? So we've got KSI out here. No, at least 3 samples every 20 feet. And so we've got the extent of where the barns were. Well, we found an area map in 1940. The farm was there in 1940, 1950. So there hasn't been any animals penned up or any manure for 70 years. And those 3 tiles that go through where the barns are carry the most phosphorus. And even with them included, in the 36 tiles, we only lost 14% of the vegetation. Now, these are all indications. That's what's coming out of this field. So, but we explain on this. So even
question, have you looked on those tissue tests, the N to K ratios and the N to S ratios, and do they change as you use cover crops? Because the thing, so as you change that N to K ratio, you'll get by with a lot less N. The normal number I have at the research farm is 60 pounds less per acre. You'll achieve the same yield. Secondarily, as we go into F, if we're not achieving, and it kind of depends on which university you play with, but the soybean yields, you know, we're missing an easy 14 to 20 bushel, and say 97, that starts to get you to those prairie pearls. You know, it's high yield bean, and that tells me that the ratio, you know, I can see by this in the top leaves here, it looks like your ratio is pretty decent. Your lower corn stalks is red, and that means you got too much N for your K. And so you can start to see pieces in your tissue test to really maximize the N efficiency. In other words, you can get by with a lot less N if you maximize your S and maximize your K. And then to hear you say, well, you're not putting on any for the last few years of K, I don't know if you're putting on any yet. But that will change totally. And as you go into a corn on corn production, you know, it'll start to really change your efficiency in the end. In fact, most of the data that Dan provides cuts off at about 200, 220, 230 pounds of N. It tips off.
185 is about the breakdown area.
And so if you aren't applying S, you've created that graph. In other words, and you think about a 400 pound, 500 pound bean crop, that N to S ratio being 14 to 1 or less, you aren't going to have any efficiency. That bean will stay green, but it won't convert the nitrate into usable something to be able to produce soybean.
Since we got the F farm on it, we have NPK high, NPK in soil, NPK in plant on corn and soy. So we do a whole plant analysis of physiological maturity of both the corn and the soy. Yeah.
And cover crops, by definition, depending on what they are, should be able to start to pull loose a little bit of that P and K. And if you aren't, then, you know, it starts to change. Your own practices are kind of creating some of your graphs, which is not totally what farmers don't think about, right? But it's just fact.
That's kind of interesting because we've got in color-wise and yield-wise up to this year, we can see all 6 segments from 0 to 250, you know, in color, and there's a yield increase, but like you said, it tops off with that 170 to 180.
And you guys are probably just so higher than the latest stuff we came up with. Southern Illinois needs more nitrogen than what they've been getting credit for.
Typically, we're running above that NRCN.
I think you've got it up, it's up to 200 or 210 now.
So, as you travel here today, watch as you leave and travel back to wherever you came from, and see the tops of these corns, how it's kind of green at the top, the leaves have that light green, and as you get closer to that little swale up there, they're starting to yellow out, and you'll see some that are just turned bright yellow at the top, and they'll be dark green towards the ear leaf in the field. That's astrocytic. Huge astrocytic. That guy, whoever it is manipulating it into estimation. So all these pieces are what really help elevate customers' efficiency and yield and population. You know, what population of corn and beans are you planting there?
2,000 corn and 165 beans. I think we drilled those. That will
Okay.
that should cover all.
Yep.
Being fully treated with Rico and everything. So on your selection for your
try to
creating a problem.
go with what the landowner, basically the farmer wants to do. They look at policy someone. This past year, the year before, we had some Lewis hybrid and we had now this year we went all with Beck. So the dealer's right down the road here, and he stores it for me until we need it. So I've got 108 days Beck in the treated areas and 111 day in the non-treated areas. And they're CC hybrids. They're recommended. Jeff John farms all the way around us. They pretty much know what hybrids work in this soil.
Right.
And so he's farming the same thing we're farming, and his son kind of makes a recommendation, or he did this past year.
The reason I was asking, because some of the places higher where you have more topography and everything, you have hybrids. They don't know that you put the racehorse on these type of soils, and you put the defensive hybrids on the other. And some of the racehorses depend on more spoon feeding than the ones that we put on the rolling topography. And that's why I'm curious as the type of variety you're selecting out here. To me, you'd be putting, the racehorses on them. They need to be spoon fed more than the ones that I grow on 5 to 7%.
We don't see a lot of variation in the yield process, even with the treatment, except the low end one is always lower yielding. The fall loses 30% of the tile load, and the fall system yields about the same as the spring system. So we do only plant, but when he comes in and plants, we have to do everything. It has to be done the same day. So he plants the one hybrid and all the treatments first, and then we load up and plant the non-treated areas next. The same thing with soybeans. Everything has to be planted basically the same day, so it doesn't get out of kilter as far as time.
And we haven't been using these soils out here. These are lake bed soils, poorly drained. So we go with,
one that can handle the.
You probably use it. Well, I try to pick out ones that have pretty good defensive, as well. Drought tolerance. I mean, you don't think about it, but yeah, you always kind of need drought tolerance, and a lot of the hybrids have pretty good, disease tolerance.
The average yield since we last 4 years, I'm not counting this year, so 4 years prior has been 200 bushel corn on the average on this farm. Soybean average is right at that 65. Whether we plant it in April, we plant it last day of May, we basically get the same yield.
What do you find for a yield response with cover crops in front of your corn?
This year, actually, more biomass this time. We have other studies where we are looking at cereal lines. If the cereal lines does so well, maybe that does so well that a cover crop every other year will be out there better than nothing. And
On your
Planting those beans green, or are you killing the rye?
yeah, we're killing it. Now there's a plant a couple times. Here
on the corn, we terminate ahead of planting, 2 weeks ahead of planting. The soybeans, we're terminating right whenever John has to come in and pull biomass. Planters usually coming in the next day, so I'm terminating the day they pull the biomass. So
that was the last couple of years because
it's basically green. It's always basically on the soybean.
How big is that rye at that point in time here?
Depends on what the soil dictates when we can plant over here. And so it'll be anywhere from knee high to headed out. In 2019, it was this tall and headed out. And we actually he planted it, we brought a crimper in and laid her down. I could have planted non-GMO beans. We did some stuff in another part of the field where we had a really thick stand of Cerelac. We crimped it. We didn't have to spray it. It just held. So then we also see the benefit of the winter annuals where the cereal rye is. So the butterweed, the yellow rocket, and the mare's tail have disappeared in those treatments. And side by side, you'll see that problem. That's what that gator with that little sprayer on there. I mean, Eric and I, we spray 200 acres a year with that. Put 75 gallon in and spray. Put a 2630 monitor on it. Yes, low. We have to spray our burn downs based on time and everything. Low decides we go ahead and plant. Sends John out to get biomass samples. We got to terminate. You can't rely on somebody that says, well, we'll be there in 2 or 3 days, because what happens is it rains and it doesn't get sprayed. And John has to go take his biomass samples again. That's not a happy camper.
When it's too windy to use that day?
When it's on you.
The advice he gave me. You're burning and it hits the side of your face, it's too windy.
They've been on me about that. Yeah. That's been a handy little sprayer. We can take it out in 5 minutes and self-contained. It's like a pickup truck sprayer on its own gator. I put spacers on it this spring, so I don't have to work so hard to straddle 30-inch rows in corn. So we do sometimes have to do other things with it too, other than just the burn. So it's kind of handy.
A lot of what we do equipment-wise is on a smaller scale, just because we don't have thousands of acres. But we're trying to plan everything and do everything based on farmers and farming thousands of acres. Don't look at that and say that's not practical.
Fill in when the retailer can't get there and do it on time. This is the tractor and toolbar I use for the NREC trials. It's got we can map the trials. We also use it out here for all the treatments. So we'll come in and based on what the farmers are doing around the area, if they're putting on fall nitrogen, if it's in November and the temperature's below 50, we'll go ahead and put on nitrogen. If they're going earlier, we'll wait until the soil temperature is 50 degrees. Spring of the year, it's based on soil conditions and what other people are doing as far as that goes too. The way that's set up right now is, so you've heard Lowell talk about RTK between the rows, or strip between the strips. So as soon as these beans are harvested, Eric's in here putting the strips in. We skip the nitrogen at that time. And then when it becomes time to do the nitrogen, for the temperatures below 50, we'll come in with this and we'll side dress those strips. Those are those low disturbance jetter units on there. They call them a high-speed unit, but we don't go real fast with it, but we do use those because they don't disturb the residue. They go right through it. They go through if you have cover crop or whatever, they go right through that too, without making much of a mess. It's got insert injector on it, and then mapping is done by ag leader inside the cab. It's a cab stand monitor, so each row unit has its own pulsing flow, and then there's some other equipment in there that tells us what's going on with the nitrogen that's going out. We can pull a 1,000-gallon wagon with this, but what we usually do is hook the wagon up and then fill the little tank on there's got a scale, so it's 500 pounds. We'll run our treatments in a non-trial area and get that weighed out and figure out where we need to be with our system. Same thing with the NREC trials that I use this on. We do the same thing. We weigh in a non-trial area and make sure we got the treatments are getting put on correctly. That tractor's been to Atlas, Illinois over the Mississippi River. It's been up to near Galena the last couple of years. So
you're using the same applicator for fall application and spring application?
No. This, you guys want to walk over this way, because it is. So this base unit with the scale on it came from John Deere when we started. They had a system of they had their system on here of the high-speed units. I didn't like theirs; they weren't working good. So we had another bar built that is an 8-row bar for fall that is not set up to time. So in the fall on normal NREC trials, we'll do that. But I have to switch back or do this first. So I use this to do this farm here because I'm side dressing the strips. So, but it's real easy. There's 3 sets of bolts you take off and pull away from this, and I got another bar that we back into and bolt on right here. All that stuff stays, and you just change the hose. The we can change it. Jason and I can change that in about half a day. I think it just matters changing things in the monitor and set it up.
So you're putting that fall nitrogen down.
Right. What it's going on a standard 2 ball night. It's 830, but not in the row. It's not. It wouldn't follow the strip. Well, yeah, it would follow.
Yeah.
It would follow the strip till, but we don't want to disturb the strip. That's why it's side drift strips. That makes sense.
So you're building strips, but you're not planting. You're building strips with no nitrogen on it to plant on, but then you're putting the nitrogen off to the side.
Right. Side drifting strips in the fall.
So the nitrogen being placed with this in the fall is not going to be at what Jeff and I use the typical indicators going.
No.
Correct?
No. And the reason for that is if we don't do the strips right away, if we wait till so this is trial. If we wait until November 1st, we may not get strips in. The strips have to be made for us to make this work. So that's why this is the nitrogen applicator for all the nitrogen. I do the same thing in spring.
The strip so far is what is it?
It's an 830.
830. Is it like a gladiator? Is it
We just got a gladiator that we're going to be. Anthony Montag coming out and put this unit on there. But we've been using the Heinecker bar that Eric's got, and it's capable of anhydrous. We did that 1 year, and we almost didn't get our strips made because the weather problem. So the recommendation for me is get the strips made. We got to have strips, and then we'll side dress.
How deep can you put the ammonia down?
5 inches. It's sealed. I mean, as long as it's sealed, we're good.
Where we go, 5, 6 inches, just not deep enough to see.
And this rig doesn't tear up the. He was planting one day. Here and I had some other things to do that wasn't in the key house. Straight up. Planting one day, and as he planted, I was planting that. You don't throw any soil. We did put an NREC trial in over at Springfield. Dowson's farming for farm manager over there. I can't think of his name. He has a bunch of stuff custom done. But anyway, we pulled in there and the clods were as big as my head. And they planted a couple wet and the corn was just spiking. And we recalibrated this and slowed it down and we were able to put that on without rolling any dirt. Doesn't work for you.
So, if I understand correctly, when you're putting out fall or spring ammonia to run trials, you're actually in the middle of the row or somewhere.
Between the row. Everything is between the row. The strips have been made.
Here, just a quarter of the row over there.
Well, I mean, he's RTK when everything he does, and this is full RTK also. So we're using the same. We're actually using the 2630 is exchanging headings and stuff.